Our today's topic is trigonometric identities. Essential question of the day is, what is an identity? How do I use trigonometric identities to prove statements? How do I use trigonometric identities to solve equations? Some of the key terms which we will be using in this session is addition identity for cosine. So our formula is cosine of x plus y is equal to cosine x cosine y minus sine x sine y. Second identity is addition identity for sine. Sine x plus y is equal to sine x cosine y plus cosine x sine y. Our next identity is for tangent. This is also known as addition identity for tangent. Tangent x plus y is equal to tangent x plus tangent y divided by 1 minus tangent x tangent y. Next we have double angle identity for sine. So when we say double angle, it means it's like 2x. So sine 2x is equal to 2 sine x cosine x. Similarly, we have double angle identity for cosine. Cosine of 2x is cosine square x, and which is also equal to cosine 2 cosine square x minus 1, which is also equal to 1 minus 2 sine square x. Next we are having double angle identity for our tangent. Tangent 2x is equal to 2 tangent x over 1 minus tangent square x. So next we are having our identity. Those are also known as half angle identity. So we have half angle identity for sine. This is your sine x over 2. This means sine half. Sine x over 2 is equal to, we have plus and minus radical of 1 minus cosine x over 2. Similarly, we have half angle identity for cosine. That's cosine x over 2 is equal to plus minus radical of 1 plus cosine x over 2. And for tangent, we have tangent x over 2 is equal to plus minus a radical of 1 minus cosine x over 1 plus sine x, which in turn simplifies to sine x over 1 plus cosine x. So I will explain to you how it gets simplifies to this part over here, sine x over 1 plus cosine x. So let's see, do we have any other? Yes, so we have some more identities. These are known as subtraction identity. So we have subtraction identity for cosine. It is cosine of x minus y is equal to cosine x cosine y plus sine x sine y. And for sine, it is sine x minus y is what? Sine x cosine y minus cosine x sine y. And similarly, we have for tangent x minus y is what? Tangent x minus tangent y over 1 plus tangent x tangent y. Now next is our even function. We have learnt about even and odd functions in the previous sessions also. Even function, a function with symmetry around the y-axis that satisfies a relation f of negative x is equal to f of x. Those functions are called even function. An odd function are functions with symmetry about the origin that satisfies the relationship f of negative x is equal to negative f of x. Those are known as odd function. And then we are having Pythagorean identities. Cosine square theta plus sine square theta is equal to 1. Then we have 1 plus tangent square theta, which is equal to secant square theta. And 1 plus cotangent square theta is equal to cosecant square theta. Our first question says verify the given identity. So when we say verify the given identity, what does it mean is, it means is we have to either we can take the left side over here and we have to prove it is equal to the right hand side over here, or we can use the right hand side term and we can simplify to become make it equal to left hand side term. In this question, what is given is, I can see from the left hand side, I see I have too many terms over here, so I will use this left hand side over here. So I'll write over here left hand side. So since this is my cosine cos square theta minus 1, let me rewrite it over here. So my left hand side is cos square theta minus 1, and this is my tangent square theta plus 1. So what I will be doing is I will be using only few formulas over here. In this case, I'm using my trigonometric ratios. tangent theta is equal to what? Sine theta over cosine theta. So this is the formula which I am using over here. So, and I will not do anything with my this cosine square theta. Cosine square theta minus 1, and this will be what? This now, since this will be my sine theta over cosine theta. Now in this case, what is happening over here is there's a square over here, so this means this will become square over here plus 1. Now what I can do over here is I can solve this part. I can take the least common denominator and I can rewrite my next step like this: cosine square theta minus 1, and this part will be what? Since I'm taking the least common denominator, cosine square theta, this will be my sine square theta, and this will be my plus cosine square theta. Now if you remember on the previous slide I have shown you, we have some identities also. So we have a Pythagorean identity which is like this: sine square theta plus cosine square theta is equal to 1. So what I will do is I will look at this part over here and I can see it says sine square theta plus cosine square theta, that I can rewrite it just 1 over there. So my next step will look like this: cosine square theta minus 1, and this will be my 1 over cosine square theta. So what else I can do after this is, since there's nothing over here, I'll just put 1 over here and I will simplify this further. So when I do this, it is my like cosine square theta minus 1, because when I multiply this my numerator, I will get itself, and the denominator will be what? Cosine square theta. Okay, so what else I can do over here is, now I want you all to pay attention to this part over here where it says identity. So what I can do over here is I can, this is my, okay, I can, if I am subtracting cosine square theta over here, if I'm subtracting cosine square theta over here, so I will be left with the sine square theta is equal to 1 minus cosine square theta. So I got one more identity over here. So over here you can see it says 1 minus cosine square theta. I can also rewrite it like this also: 1 minus cosine square theta. So I can rewrite it like this also, and I will show to you by using the FOIL method. See, if I'm using the FOIL method, negative 1 times 1 is what? Negative 1, which I am having over here. And when I do negative times negative, it becomes positive cosine square theta, which I already have it over here. So that's okay. So the reason why I was doing this is I was trying to make it in terms of this, because my right hand side is tangent square theta. I just want to do something, I will be end up with tangent theta over here. So now when you see 1 minus cosine square theta, so what is the identity? We can also write it as equal to sine square theta. Now, so what happens over here is it brings us back to where we started. So you see over here, let me zoom out so you can see my whole screen over here. Now, so what was happening over here is, what is the formula for tangent theta? There's your sine theta over cosine theta, and you can see it's your sine square theta over cosine square theta. So this means I can write it like this. Since this is square, I can write it like this. Now my next question to you is, do you see this is equal to a right hand side term over here? Yes, it is equal to right hand side term. So we were able to prove that what this is an identity. So I can write over here, yes, it has been verified that it is an identity. So it is an identity because I was able to prove my left hand side is equal to what? Right hand side. That's my identity. So this is how we solve the questions which requires us to verify the given identities. Now our next question again is the same, say verify the given identities. So we have to verify tangent square theta plus 1 divided by tangent square theta is equal to cosecant square theta. So let's start working on this. I will start from the left hand side over here. So this is my tangent square theta. Okay, let me rewrite it over here. Tangent square theta plus 1 divided by tangent square theta. Now what I will, as I mentioned earlier, I will only use only few of these identities over here. I'm just using this formula: tangent theta is equal to sine theta over cosine theta. You do not have to memorize all the different formulas which I gave you. Just pick few and just use only those to solve any question. You can solve any problem which involves verification identity using some few formulas. So I will be using tangent theta is equal to sine theta over cosine theta over here. So when I see in the numerator it says tangent square theta, I can write it over here: sine theta over cosine theta. Now you see there's a square, so I have to put what? A square over here, and there's plus 1 over here. Similarly, in the denominator, it will be what? Sine square theta over cosine square theta. So let's take the least common denominator over. Let's try to solve the numerator part over here. This will be my cosine square theta, and this will be my what? Sine square theta plus cosine square theta. And divided by, in the denominator I have not done anything, it is just sine square theta over cosine square theta. Now we can straight away cancel these two over here because they are same, so we can cancel those. So next term will look like this: sine square theta plus cosine square theta over sine square theta. Now you remember on the previous slide I have given you the Pythagorean identity. Your Pythagorean identity is what? Sine square theta plus cosine square theta is equal to what? It is equal to 1. So this means my numerator part over here, I can replace this by what? By its value 1 over here, because this is an identity. So 1 over sine square theta. So now for this, so I will use another formula over here, my cosecant reciprocal ratios. From the previous lesson which we learned, cosecant theta is what? 1 over sine theta. So this means what? Instead of 1 over sine square, I can write it like this: cosecant square theta. Cosecant theta, since this is square, it will be this. Now my next question to you is, this is my final answer. Do you think when you look at the right hand side over here, do you think these two look same? Yes, because this is an abbreviated form. This is what I can write over here. This is equal to RHS, or we have verified it's an identity. I can write over here, I have verified that it is an what? It is an identity. So these are few formulas which I will be using to solve these problems. Okay, now let's move to another problem. It says verify the given identity tangent B plus cotangent B is equal to cosecant B times secant B. So this says, so what I will do is I will take my left hand side over here. So left hand side part says tangent B plus cotangent B. So again I'm using my ratios over here. Tangent theta is equal to sine theta over cosine theta. So I'm using that formula over here, and similarly I have for cotangent theta, that's my cosine theta over sine theta. So what it will change to, what it will change to sine B over cosine B, plus this will be my cosine B over sine B. So what I will do after this, I will add two of these fractions over here. So this will, my denominator will be cosine B times sine B, but over here this will be my sine square B plus cosine square B. I wrote theta over here, should be B because I'm having an angle over here. This is my B over here. Now so after this, what I will do is I will use my Pythagorean identity over here. Sine square theta plus cosine square theta is equal to what? 1. So what is my numerator? This, you see, this is your sine square B plus cosine square B, which will be equal to 1. So my next step is this: cosine B times sine B. I will pause over here and I will see, does this satisfy my condition? No. But on my right side over here, I have cosecant beta and secant B over here. So what I can do over here, I can rewrite it like this also: cosine B times 1 over sine B. Now these are my trigonometric reciprocal ratios. So this is a 1 over cosine B. So that's your formula. Secant theta is equal to what? 1 over cosine theta. Reciprocal trigonometric ratios. And similarly, I have for cosecant theta, that's what? 1 over sine theta. So this means after this step, I can rewrite it 1 over cosine B as what? Secant B over here. And I can rewrite it as what? This cosecant B. So let's look over here. So I was supposed to prove this is equal to cosecant B times secant B, which I have the similar over here, secant B times cosecant B, or I can rewrite it over here, or CSCB times secant B. So this means I am able to prove that this is equal to my what? Right hand side over here. So I can write away, hence verified, it is an identity. So I write away, hence verified, it is an identity. So only use these formulas which I have given over here. This is one of this I'm using one over here. These are few. That's one which I'm using. You should use only these. Let's proceed to the next slide. Our next question is find all solutions to each equations on the interval 0 to pi. So let's work on this problem over here. So it says 5 cosine x is equal to 3 cosine x plus radical 3. So what I will do is I can see cosine x on both the sides. So this is giving me a hint. I need to subtract 3 cosine x from both the sides. Okay, let me zoom, since I zoom in. Alright, so let me erase this and then we go. So I will first of all do is I will subtract 3 cosine x from both the sides, because I'm trying to bring all my cosine x terms to what on one side over here. So I will cancel out over here. So this side it will be 5 cosine x minus 3 cosine x is equal to radical 3. Now as these two are like terms, I can see cosine x, so 5 cosine x so minus 3 cosine x will give me what? 2 cosine x is equal to radical 3. After this what I will do is I will divide both the sides by 2 and I will be left over with cosine x is equal to radical 3 over 2. So what it tells me is my value of what I'm looking for is I'm looking for on the interval 0 to 2 pi, when is my cosine is equal to radical 3 over 2, and this is at x is equal to pi over 6 and x is equal to what? 11 pi over 6. So at these two places my value of x, this is or my cosine is what? Cosine is radical 3 over 2. So this is how we solve the equations over here. Let's try one more question over here. Now the next question says 2 sine x cosine x is equal to radical 3 sine x. So what I will do is I will first of all bring all of my terms on one side. How I can do this is I have to subtract radical 3 sine x from both the sides. So I have all of them on one side over here. So my next step is 2 sine of x cosine of x minus radical 3 sine of x is equal to 0. So what I can do is I can factor those over here, since I can see sine x and sine x coming in both of these terms. So I can factor this sine x. So it will be left over here 2 cosine x minus radical 3 is equal to 0. So what I will do is I will equate them. Since I'm equating them, it will be sine x is also equal to 0. And what else? I have 2 cosine x minus radical 3 is equal to 0. So at this point, at this part over here, what I can do is I can simplify this further. I can add radical 3 to both the sides. This will be cancelled out. So 2 cosine of x is equal to radical 3, and I will divide both the sides by 2 over here. So I will have cosine of x is equal to radical 3 over 2. So what I'm looking at on the interval 0 to 2 pi, when is my sine x equal to 0? And my sine x is equal to 0 at x equal to 0 and x is equal to pi. Now what about when is my cosine x equal to radical 3 over 2 in the interval 0 to 2 pi, and that is at these two places over here. X is equal to pi over 6 and x is equal to what? 11 pi over 6. So what I have 4 solutions to this equation over here. X equal to 0, pi, 0, x equal to pi, x equal to pi over 6 and x equal to 11 pi over 6. So our next question is 2 sine square x plus sine x minus 1 is equal to 0. So what I will do over here, I will use the u method over here. I will just assume let sine x is equal to u. So if I do this, it will be 2u square plus u minus 1 is equal to 0. So what you should do first over here, as you see this coefficient of u square is 2, you take this 2 and multiply with negative 1, your answer will be negative 2. So now you are looking for two numbers. On adding or subtracting gives you the middle number over here. This means the coefficient of this middle term over here, that's your 1. So straight away I came over, if I have 2 times negative 1, it gives me negative 2. But when I subtract, I will end up with this only. So I can come back over, I can rewrite it over here, plus 2u minus u minus 1 is equal to 0. So in this case I can factor this part over here. This is my 2u and that's my u plus 1. Over here I can take negative 1 as common over here, so I will have u plus 1 over here. So in this case, what my next step will be, since I can see u plus 1 is common over here, so that will be my common factor, and this will be my 2u minus 1 is equal to 0. Now since those both factors are equal to 0, I can set it up equal to 0. U plus 1 is equal to 0, and another one will be 2u minus 1 is equal to 0. So it will be I will subtract 1 from both the sides. I will have u is equal to what? Negative 1 over here. And in this case, when I will add 1 to both the sides over here, cancel out, and 2u is equal to 1, and which will give me what? U is equal to 1/2. Now remember, u is what? U is equal to sine x. So it will look like this, or sine x is equal to negative 1. Over here it will say or sine x is equal to 1/2. So what we are looking for? We are looking on the interval 0 to 2 pi, when is sine equal to negative 1 and when is sine is equal to 1/2. So our answer is what? So it is at two different places. Our values are x is equal to pi over 6, and then we have 5 pi over 6, and then we have 3 pi over 2. So at these values of x, we will have cosine x is equal to 1/2 and sine x is equal to negative 1 over here. Now we will talk about addition and subtraction identities. I have already given you in the first part over there when we started our session. I have given you that key terms over here. So we have sine x plus y is sine x cosine y plus cosine x sine y. And similarly, we have for sine x minus y, we have sine x cos y. Only the difference, the minus sign over here, cos x sine y. And then we have cosine x plus y, it is your cos x cos y minus sine x sine y, and for cosine x minus y we have cosine x cosine y plus sine x sine y. Now for tangent x plus y, our formula is tangent x plus tangent y over 1 minus tangent x tangent y, and then we have tangent x minus y equals tangent x minus tangent y over 1 plus tangent x tangent y. So I will be using these addition subtraction identities in my next part over here. So let's go to the next topic. So our question says find the exact value of sine 15 degree. So what I can do over here is I can rewrite my sine 15 like this also, sine 45 degree minus 30 degree. I can rewrite it. When I solve it, I will be ending up with this. So I will use my addition formula for subtraction formula for sine. Sine x minus y is equal to what? Sine x cosine y minus cosine x sine of y. So in this question, our x will be what? In this part, x is our 45 and y is this. So when I will expand it, it will look like this to you. Sine of x, you can see over here x, so this is your 45. Then we have cosine of 30 degree, okay, minus cosine of 45. Why 45? Because this x is over here, x is over 45, and then it's your sine of 30 degree. So our values are sine 45 is what? From the unit circle, radical 2 over 2. Cosine 30 is what? Radical 3 over 2. Minus cosine 45 is what? Radical 2 over 2, and sine 30 is what? 1/2. I got these values from my unit circle. So what I will do is I will just solve them. So this is my radical 6, and 2 times 2 is 4, minus, similarly over here I will multiply numerator with numerator, denominator with denominator. Radical 2 over 2 times 2 is 4. Now you can see both our denominators are same. If I want to subtract this, my answer will be radical 6 minus radical 2 over 4, and this is my answer for this problem over here. So our sine 15 degree is what? The exact value of sine 15 degree is radical 6 minus radical 2 over 4. Let's proceed to another problem. So now next problem is find the exact value of sine 75 degree. So what I can do over here, I can rewrite it like this, sine 45 plus 30 degrees. So which will make it what? It is my 75 degree. So I will use the addition formula over here. Sine of x plus y is equal to what? It is my sine x cosine of y plus cosine x sine of y. Alright, so this is my x over here, that's my y over here. So let's expand this formula. So it will be sine 45 degree cosine 30 degree plus cosine 45 and sine of 30 degree. So sine 45 is what? That's your radical 2 over 2, and this is your 1/2, and this is yours radical 2 over 2, and that's your 1/2. So let me simplify this. So this will be my radical 2 over 2 times 2 is 4 plus sine radical 2. Okay, I think I messed up somewhere. Cosine 30 is not 1/2. Cosine 30 is what? Cosine 30 is radical 3 over 2. So this means that this place it should be what? It should be radical 3 over 2. I messed up over here. So, and this part, what will be happening when we multiply these two, radical 2 times radical 3, it will give me radical 6, and over here that's the 4 over here. So my final answer over here, it will be radical 6 plus radical 2, and this is my 4. So this is my exact value of sine 75 degree. So what I did in the previous problem, this one only thing difference is I'm using this formula over here, sine of x minus y. That's okay, addition identity I'm using over here. In this case I got my answer radical 6 minus radical 2. Over here I use the addition identity over here, and I ended up with this answer. I think only the difference was the plus and the minus sign. Okay, now let's look at our question over here. It says tangent of 7 pi over 12. So what I can do is I can rewrite it like this also. Tangent of simpler if I do is 4 pi over 12 plus 3 pi over 12. Yes, it just makes some sense over here. I can just do it. That's it. I can do it. Or I can simplify it. And I can write it like this also. Sorry about that. There you go. I can write it like this, tangent. So 4, and this will be my pi over 3 plus, I can do it, this will be my pi over 4. So now what is my addition formula for tangent x plus y? So it is yours tangent x minus tangent y over 1 minus tangent x times tangent y. So this will be my x, that's my y. So let's plug in the values over here. Tangent x, this will be tangent pi over 3 minus, is it a minus or plus? It should be plus over here. There's a plus over here. This minus, only one place minus comes. So plus tangent y over 4, pi over 4, divided by 1 minus tangent pi over 3 times tangent pi over 4, and I'm doing remaining part over here. Let's change the color. So what is your tangent pi over 3? That's your radical 3, and tangent pi over 4 is 45 degrees. That's your 1. This is your 1 minus, similarly over here tangent 3 times 1. So your step will be radical 3 plus 1 over 1 minus radical 3. So by looking at the denominator and numerator, I can see those terms are same, only the difference is the positive or negative sign over here. So I can rewrite it like this, 1 plus radical 3 divided by 1 minus radical 3. So this is one of my answer, but I will not stop over here. What I will do is I will rationalize the denominators. I will multiply and divide by what? The conjugate of this. So 1 plus radical 3 over 1 plus radical 3. When I'm doing it in the numerator part while using the FOIL method, I will have 1 plus 2 radical 3 plus radical 3 whole square. In the denominator part, we are using difference of perfect squares. It will be 1 square minus radical 3 whole square. So let me go to the next step. I'm just doing over here, just going different directions. So it is your 1 plus 2 radical 3, and that's your 3, because radical, this will be 3 over here, and that's yours 1 minus 3. So my next step, I'm going in this direction over here. This is my 4 plus 2 radical 3 divided by negative 2. So next time I'm going in this direction, I can take 2 common over here, 2 plus radical 3 over negative 2 over here. I can cancel this, I can divide this, and my final answer will be what? Negative 2 minus radical 3. So this is my exact value of tangent 7 pi over 12. Thank you.